In this first question, we are asked to find the domain and range of each relation and to determine whether the relation represents a function. So in order for a relation to become a function, what we need to establish is that every input has only one output, right? So the easiest thing for you to remember is something like this. So for example, if you have a graph like this versus a graph like this, right? Now this is a function and this is not a function, right? Because here you see how if you want to look at this, there are two input values, this and this. They both have the same output, which is fine. However, here what happens is that this input has more than one output. So what we don't want to have is one input having more than one output. So that makes this disqualified as a function. So let's look at this. Here you have -4 is an input having two separate outputs. So no. This absolute value of x function relation is a function because every input has only one output, whereas this is not a function because this can be rewritten as y equals plus or minus square root of x, which means every input will have two outputs, right? So that is not a function. So in the next question, we are asked to evaluate the function at the different inputs. So how do we do this? The first one is asking you to find f of 0. So if you're asked to evaluate f of 0, you are just going to replace every x with whatever number is in the place of x. So in this case, it is 0. So I'm going to replace every x with a 0. And I will simplify. So 2 times 0 is 0, 0 plus 1 is 1. So I end up with 1 over -5, which can also be written as -1 over 5. Part B is f of 1. Do the same thing. 2 times 1 plus 1 over 3 times 1 minus 5. Simplify. 2 plus 1 is 3. 3 minus 5 is -2. And that is this. F of -1 is 2 times -1 plus 1 over 3 times -1 minus 5. So that is -2 plus 1 is -1. -3 minus 5 is -8. So that is 1/8. Part D is asking you f of -x. So again, every x in the original function is replaced with -x, right? Then you simplify. 2 times -x is -2x plus 1 over -3x minus 5. And you can just leave it like that. So I'm going to duplicate this side so that we can do the rest of them over here. Okay, so we finished till part D. Now I'm going to do part E onwards. Okay, part E was asking you to find negative of f of x. So what they're asking you is negate this whole thing, right? So the now negative is now on the outside. Now, when the negative is on the outside, please do not make the mistake of distributing the negative sign to both the numerator and the denominator. Only to one, right? Because if you do to both, then you're actually not negating. So if I just distribute it to the numerator, I end up with -2x minus 1 over 3x minus 5. Part F is f of x plus 1. So again, I'm replacing every x in my function with x plus 1, and then I will simplify. So you're going to distribute combined like terms and so on. I'm just going to do it all in one step. So I have 2x plus 2 plus 1, that is 2x plus 3 over 3x plus 3 minus 5 is 3x minus 2. Then f of 2x, again, replace your x with 2x and simplify. So when I do this, what do I have? 2 times 2x is 4x plus 1 over 6x minus 5. And finally, I have f of x plus h. Do the same thing. 2 times x plus h plus 1 over 3 times x plus h minus 5. Simplify. 2x plus 2h plus 1 over 3x plus 3h minus 5. And you can leave your answer like that. Find the domain. So what is domain? Domain is all the x values or the input that can go into the function such that the output remains a real number, correct? So what are all the allowable values of the input? In this case, the variable that is used to denote the input is all x, right? All right, so we had to find all the x values that can go into the function so that f of x or g of x or h of x remains a um, real value, right? Okay, so let's see. The first one, no matter what I input for x, the output will be defined, right? Because I can input a negative number, positive number, whatever number I input, any real number that I input, my output will be defined. So my domain for f of x equals x squared plus 2 is all real numbers. So we are going to write all our domain as in an interval notation. So which means here I'm going to say that all values from negative infinity to positive infinity are allowed. Okay, so in the next one, I have a fraction, right? And not only do I have a fraction, I have a variable in the fraction, in the denominator, okay? So whenever you have a variable in the denominator, you have to make sure that 2x squared plus 8 is never equal to 0, okay? So fortunately for us, no matter if x is negative or positive, 2x squared is going to become a positive number because when you square a negative, it becomes a positive. So a positive plus a positive is still a positive. So there is no x value that is going to make the denominator 0. So which means the domain of this is also all real numbers because there is nothing that can make that denominator 0. So in this next one, again, my goal is to make sure that my denominator never equals 0, right? Now, there are multiple values of x that can make this denominator 0. What could they be? So let us see. So if I factor the x out from it, this is what I will have. This can be factored further, right? So which means x cannot equal 0, x cannot equal positive 2, and neither can it equal negative 2. So there are 3 exclusions here, right? So if you want to plot it on the number line, what you're pretty much saying is that negative 2 is not allowed, 0 is not allowed, 2 is also not allowed. So I'm having 3 numbers which are not allowed to become the input of g of x. So what is the domain of G then? The domain of G will be negative infinity to negative 2 union, negative 2 to 0 union, 0 to 2 union, 2 to infinity. So basically you have to write each of the 4 intervals, right? This is your interval 1, interval 2, interval 3, interval 4. The last one, the domain of h of x, which is square root of 3x minus 12. So now we have an even radical. So for an even radical, what I need to make sure is this expression within the radical always stays as a non-negative number, right? Which means greater than or equal to 0. So I solve x has to be greater than or equal to 4. So the domain will be 4 to infinity. Okay. So we have to find the difference quotient in the next question. So the first part of the difference quotient is to find this. This is the first part, right? So you can either do it all in the whole expression, or you can do it separately. So let's try to do this separately. Let's evaluate f of x plus h first. So wherever you see x, replace it with x plus h and simplify. Okay. So x plus h the whole squared is x squared plus h squared plus 2xh. Now I'm going to distribute. And I will combine any like terms if I have. Here I don't have any like terms, right? Okay. All right. So now this is where I am. So I have evaluated it and I have found out f of x plus h to be 3x squared plus 3h squared plus 6xh minus 2x minus 2h plus 6. So this is what we have. So now I'm going to find the difference quotient. What is the difference quotient? It is nothing but f of x plus h minus f of x all over h. So I will replace this for f of x plus h. And then I will subtract from it f of x. You have to use parentheses here so that you don't make mistake with the sign. So now if I distribute it, what will happen is this. So if I were to distribute, what will happen is that this is going to become negative 3x squared plus 2x minus 6. So I'm doing it all in one step for lack of space, right? So if I were to distribute, this 3x squared will become negative, the negative 2x will become positive, the positive 6 will become negative. So now let's see what will get cancelled out. The 6 and the negative 6 gets cancelled out. This and this gets cancelled out. And that's it. No, this and this gets cancelled out. So what am I left with? I'm left with 3h squared plus 6xh minus 2h all over h. Now as you can see, every single remaining term has an h attached to it, which means I can factor it out. So I take the h out of the 3h squared, I'm left with 3h, then plus 6x minus 2. So now at this point, I can cancel this. So my resulting answer will be this. Okay. So we're going to do the same thing for this problem. So the first thing I'm going to do is evaluate f of x plus h, and that is nothing but 1 over x plus h plus 3. So the difference quotient then becomes 1 over x plus h plus 3 minus 1 over x plus 3 all over h. So in order to combine the numerator into a single fraction, you can multiply both. You can do it any way you want. This is how I'm going to do it. I'm going to multiply these two. So I'll have x plus 3 minus multiply these two, because 1 times x plus 3 is just x plus 3, minus x plus h plus 3 all over x plus h plus 3 times x plus 3, and then I'll put the h from the denominator. So basically you have to combine the numerator into one single fraction, and you will have to do the keep, change, flip to do this. So if this step is confusing to you, I can do one more. So this is what you have all over h. Okay, I have to simplify this. Okay, so let's see how to simplify this, right? So when I simplify this, what is going to happen is, so this is what I have. Okay, so we have all of this. Now we have to simplify. So how am I going to do it? I'm going to do the numerator first. minus x minus h minus 3 all over x plus h plus 3 times x plus 3, and then I do the keep change flip. So this h over 1, when I flip it, becomes 1 over h. Okay, so then I cancel out whatever I can. The x and x goes away, 3 and the 3 goes away. So what am I left with now? I'm left with negative h over x plus h plus 3 times x plus 3 times 1 over h. Now I can cancel this out. So my final answer is negative 1 over x plus h plus 3 times x plus 3. Okay. So another difference quotient. All right, so let's all do it in one step. So f of x plus h is nothing but x plus h minus 2 minus this all over h. Okay, so now here, in order to simplify this, I have to multiply and divide by the conjugate of this. So like so. All right, so now if I multiply this numerator with this is of the form a minus b times a plus b, which is nothing but a squared minus b squared. Okay, so then I keep everything else as it is. So you can try to FOIL this and this will reduce to that. Okay, so if you want, you can just do it that way. So then I simplify this, then what is going to happen is this and this is going to go away. This and this is going to go away because negative times a negative 2 will become a positive. So what am I left with? I'm just left with h over h times this. For lack of space, I did that without distributing the negative sign first. So I hope that you wouldn't do that on an exam. So this and this goes away. So my final answer is 1 over this. Okay. Okay, here the question is asking you, is the point, so let me do this right away. All right, so is this a point on the graph of the function? Let's see. If this was point on the graph of the function, then this is my output, this is my input. So the question is asking you, is this equal to this? Right? So if you simplify this, negative 1 squared is positive 1. So this is negative 3 minus 5. 2 is not equal to negative 3 minus 5, correct? So the answer to part A is no, it's not. Because the output, if I substitute the input for x, that does not equal the output of 2. Part 2, if x equals negative 2, what is f of x? So basically they're asking you to evaluate f of negative 2, right? So they're asking you to replace every x with negative 2 and find out what you have. So do the square first. Negative 2 squared is 4. 4 times negative 3 is negative 12 minus 10 is negative 22. So what is the point on the graph? The point on the graph is negative 2 is the input, negative 22 is the output. In the next problem, it's asking you, the output is now negative 2, f of x is negative 2. What is x? So they're asking you to solve this. So they're asking you to solve this equation to find out what is the x value that will result in an output of negative 2. So to do that, let's bring everything over to the left side and set up an equation like this. And then let's factor, right? So negative 6. 3x is common, x minus 2 plus 1 times x minus 2. So basically the factors are x minus 2 and 3x plus 1. Set each factor equal to 0, x equal to 2, and x equals negative 1/3 are the answers to part C. Okay, so here you're just solving a quadratic equation. If you need a refresher for that, please make sure that you go and find some resource and make sure that you know how to solve quadratic equations. So now let's do part D. Part D, what is the domain of the function? So this is just a quadratic function, correct? So the domain is all real numbers. There is no restriction. You don't have a fraction, you don't have a radical, so there is no restriction. What are the x-intercepts? So to find the x-intercept, you have to set f of x equal to 0 and then you have to solve for x. Okay, so let's do that. So let us set it equal to 0 and solve. So x is the common factor. Take it out. So that means the two values of x are going to be 0 and 5/3, right? So those are the two x-intercepts. Now to find the y-intercept, you will set x equal to 0. So basically f of 0 is the y-intercept. So if I make this 0, what do I have? I have 0. So the y-intercept is 0, 0. Okay. So to find the y-intercept, you set the x equal to 0. To find the x-intercept, you set the y or f of x equal to 0. Okay, now we're going to do the same thing here. Answer part A first is the point on the graph. So let's see, let's evaluate f of 1/2 and see what happens. 2 times 1/2 over 1/2 minus 2, which is 1 over negative 3/2, which is negative 2/3, which is what the y value is. So the answer is yes, it is. If x equals 4, what is f of x? So we are finding f of 4. So we substitute 4 wherever we see x. We get 8 over 2 is 4. What is the point on the graph? 4, 4 is the point on the graph. If f of x equals 1, what is x? So they're asking you to solve this equation. Cross multiply. X minus 2 is 2x. Negative x is 2 or x is negative 2. What is the point on the graph? 2, 1 is the point on the graph. So that is the answer to part C, because x is 2, y is 1. What is the domain of this function? So to find the domain, because this one has a fraction, x minus 2 cannot equal 0, which means x cannot equal 2. So the domain is all values except 2 itself. Okay. What are the x-intercepts? To find the x-intercept, set the numerator equal to 0. So x equals 0 is the x-intercept. What is the y-intercept? To find the y-intercept, make the x equal to 0. So that means 2 times 0 over 0 minus 2, which is 0, right? So 0, 0 is both the x-intercept and the y-intercept. All right, for the graph below, answer the questions given. In which interval is the function increasing? So to see where the function is increasing, look at the graph. The graph is increasing here. It's increasing here as well as here. So these are the three areas in which it is increasing. Now, the corresponding intervals, look at the x values. So starting from -8 to -2, then 0 to 2, then 5 to 7. That's where it is increasing. What are the intercepts? So what are the intercepts? First, x-intercept, -10, 0, -5, 0, 0, 0, 5, 0. So these are the four intercepts. The y-intercept is also 0, 0. Does the function have any absolute maximum or minimum values? Yes, it has an absolute maximum, which is 10 at x equals 2 because it's the highest value this function has. And it has an absolute minimum, which is negative 4 at x equals negative 8. Find the intercepts, if any. So yes, the intercepts are negative 1, 0, 0, 2, 1, 0. So we are including both the x and the y intercepts here, okay? What is the domain and range? The domain is starting at 0, that is the domain starts at negative 3 and ends at positive 3, right? So because this is the least x value, this is the highest x value. The range starts at 0, right? 0 and goes till positive 3. Where is this function increasing? So again, the function is increasing here and here. So which is from negative 1 to 0 and 1 to 3. Where is the function decreasing? It's decreasing here and here. So decreasing intervals are negative 3 to negative 1 and 0 to positive 1. It's not constant anywhere. Is the function even, odd, or neither? So this function is even because if you flip it over the y-axis, it is going to superimpose, right? So it is an even function. Determine algebraically whether even or odd. So in order to do that, we have to first evaluate h of negative x. So we replace every x with negative x and see what happens. So this becomes negative 3x cubed plus 5. So then we compare. H of x is not equal to h of negative x, which means it is not even. And then h of negative x is not equal to negative h of x either, because if that was the case, the positive 5 should have become negative 5. So this is not odd either. So that means my conclusion here is this function is neither odd nor even. So here I do the same. And then what do I observe? This becomes this. So I compare h of x, h of negative x is not equal to h of x. So that means it is not even. However, h of negative x is the opposite of h of x. So that makes this function odd. Hope this makes sense. So in order to determine whether a function is even or odd, just evaluate the function at negative x. If h of negative x is equal to h of x, it's an even function. If it is exactly the opposite, it's an odd function. If it's neither of them, it's neither. Draw a rough sketch of the following library of functions, identity and square. For each function, create a table with 3 key points. Identify the domain and range. What are the intercepts? Is the function even, odd, or neither? I'm going to leave this alone because I will be including a separate video of all the library of functions. So this is something that I will just leave alone for now. Okay, so that's the same thing here. So these are all the library of functions. Let's do this piecewise function. Okay, f of negative 2. So the first thing you need to find out is where does negative 2 belong to, right? Which interval does negative 2 belong to? So negative 2 belongs to this interval because negative 2 is less than negative 1. So that means f of negative 2, you have to use this function to evaluate, this expression to evaluate. So f of negative 2 will be negative 3 times negative 2, which is 6. Then this question is asking you what is f of negative 1. Now where does negative 1 belong? It belongs in this interval. So the answer will be f of negative 1 is 0. Now where does 0 belong? I think this is probably a typo. This probably is this. So x is greater than -1. So x is greater than -1. So this is the interval in which it belongs. So this is going to be 2 times 0 squared plus 1, which is 1. Okay, so here find the domain of each function, locate any intercepts, graph the function. Based on the graph, find the range. So this is multiple parts. So let's do the domain first. So think of the domain, think of a number line, okay? Look at the first interval. Where does the first interval start? It starts at -2. Is -2 included? Yes. Okay. And then it goes on till 1. Then this interval picks up the 1, right? And then this interval picks up greater than 1, like that. So what is the domain? The domain is -2 to infinity is the domain. Locate any intercepts. Okay. So to find the x-intercept, we have to make the y equal to 0. So remember, a graph can have more than one x-intercept, but it can have only one y-intercept. So meaning x-intercept can come from any of the pieces, right? So let's see whether the x-intercept comes from the first piece. So to do that, what am I going to do? To find the x-intercept, I have to make the y equal to 0 and I have to solve. So if I put y equal to 0 and solve, x is -3. Now, does -3 even in my domain? No, right? So this cannot be an x-intercept. The second one is not going to yield me an x-intercept. So I go to the next one and I put it in. I solve, right? So x is equal to 2, right? Now 2 does belong to the interval. It does belong to this interval. So that means my x-intercept is 2. To find the y-intercept, I have to find where is x equal to 0, in which um, uh, interval is x greater than 0, right? Okay, I mean x equal to 0. That is this one, right? So that means I take this and I set it equal to 0. So 0 plus 3 is 3. So the y-intercept is 3. Okay. And now I have to graph. Okay, so let's see how do I graph. So what I'm going to do here is, this one is easy, right? When x is 1, y is 5. I know there is a point 1, 5 on my graph. Now this 1 is where my graph splits into two halves, right? So I'm just going to roughly draw this to tell myself this is where the split happens. So -2 to 1, I have a line that takes the form x plus 3. Okay. So now when x is equal to 1, right? When x is equal to 1, 1 plus 3 is 4. So 1 comma 4 is where that line ends. Now when x is -2 plus 3 is 1. So this is where it starts. So this is my first piece. Okay. The second piece is just a point. The third piece starts at 1. When this is 1, when x is 1, -1 plus 2 is 1, right? So I have 1, 1. After that, the graph just goes down like that. Okay. Because it is just a -1 as the slope. So, that's how it goes. So these are the three pieces of the graph. Now, based on the graph, find the range. So you see that the y values keep going down, 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 right? So that means -infinity is the lowest y value. Let's see where the highest y value is. So the graph goes till 4, but there is a split. It stops there, and then there is a 5 by itself. Okay, so that is the range. So the graph of a piecewise defined function is given, write a definition. So there are two pieces. So the first thing that I would recommend that you do is fill the easy things first. Okay. So basically in this piecewise function, an expression is going to go for this piece, an expression is going to go for this piece. But what are the easy things to fill up? Let's see this first piece. Where does the x value start? It starts at -1, stops at 0. And not only that, you see that both of these are solid points, right? So then I'm going to say it starts at -1, it ends at 0. The next one starts at an x value of 0, but it keeps on going. It doesn't stop, right? But the 0 itself is not included. It was included in the other one. So this is x is greater than 0. So all values of x greater than 0. Now the equation itself. So let's go to this first line. To write the equation of a straight line, I need the slope, I need the y-intercept. The y-intercept is right here, so this part is easy. Now what is the slope of this line? y2 minus y1 over x2 minus x1 is the slope. So which is 2 over 1 is 2. So 2x plus 2 is the equation of the first line. Now let's do the equation of the second line. So this line, the y-intercept is 0. What is the slope? y2 minus y1 over x2 minus x1 is 1. So this is the equation. I don't have to write 1x, it is just x. So I take the x and put it here. I don't have to put the y equals because this f of x equals takes care of that. So this is the equation of the piecewise function.